Hi everyone, today's topic is average rate of change, and the learning target is I can use the slope formula to calculate the average rate of change over an interval. So I included the slope formula down below. You should have this written down at the top of your page, and I also recommend that you memorize it. But basically the slope is what you use to calculate the rate of change. So you can think of rate of change and slope as basically the same thing. And I also included this meme from the show Curb Your Enthusiasm, which is because I want you to use what that guy is doing with his hands as a way to think about intervals and as a way to see a function over an interval. And to be clear, these two numbers here, -4 and -2, are not the coordinates of a point, meaning that a lot of people see this at a point right here, and they say, okay, this is my point, -4 and -2. That is not what an interval is. In fact, these two numbers are both x values, x1 and this is x2. And so you're looking at where x equals -4 and where x equals -2, and you're peeking at the space in between and where the function is in that space. All right, let's take a look at this problem, which will be a review of linear functions. It says, find the average rate of change of the function f of x equals 3x plus 2 over the interval -4, -2. The equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. You may be wondering, why does this say f of x and this say y? It's basically the same thing. You can think of a function as a machine where you plug in a value for x and then it spits out a value for y. Another way to say the same thing is that you plug in a value for x and it spits out a value f of x. So the first step is to write down your function. So you're going to copy down f of x equals 3x plus 2. Now you don't actually have to do this part to solve this problem, but I want to do a quick review about graphing linear functions. The first thing you do is find the y-intercept. So you find where 2 is on the y-axis, and you put your first point there. The next step is you use your slope formula, or rise over run, to find the second point. So the slope here is 3, or 3 over 1. It's like an invisible 3 over 1 there. So your rise is going to be 3. You're going to go up by 3. 1, 2, 3. And then over by 1. And there's your point, and there's your line. I don't want to waste your time with this example because there's a simple answer. Here the slope is 3, right? M equals 3. And what did I tell you earlier? Rate of change is the same thing as slope. So that means that from -infinity to +infinity, the rate of change is always 3. So it doesn't really matter which interval we're talking about. But when you're doing a problem like this, you still have to show your work. So I'll do the work and show it to you on the slide. So here I highlighted the part of the linear function that's in the interval -4 and -2. So now I'm going to plot the 2 points and show you how I use the slope formula to find the average rate of change. Notice how I wrote down my 2 points from left to right and then carefully labeled them with the x and y coordinates of the first point and the x and y coordinates of the second point. And finally, I plugged in my x and y values into the slope formula, starting with y2. So I did -4 minus -10, which turns into -4 plus 10, over -2 minus -4, which turns into -2 plus 4. And the final answer is 3, which we already knew, but I wanted to show you the work. So this problem is asking us to find the average rate of change of k of x equals -3x squared over the interval -1.5, 2. And you can see that this graph is curved. So it's not as straightforward as just finding the slope of the line. You actually need to identify the interval and then calculate the y value of the points that are on the graph. We can try to do this graphically. If we find -1.5 on the x-axis and move down, 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 that puts us right around there. The problem is that's not very precise. See, I can't tell if that's -6.6 or -6.7. And the problem is asking us to solve to the nearest tenth, so that's not great. And then over here, if you go down from x equals 2 and scroll down, that takes us off of the graph, so our window size isn't even big enough. So I'll show you how to do this manually by substituting values of x into the function, and also how you can pull up a table on the calculator, which is a bit of a shortcut. So to find our first point, we're going to take this negative 1.5 and we're going to plug it into our function. Just to avoid confusion here, this right here, k of negative 1.5, is not a multiplication. This represents the y value that the function k spits out after you plug in negative 1.5. This, on the other hand, negative 3 times negative 1.5 squared, is a multiplication. So that's what we'll be calculating, starting with the exponent first. So here you see we get a value of negative 6.75 for the y value of the first point, which was close to what I had estimated, but I was still off by about 15/10. Now we do the same for the second point, x equals 2, take it, plug it into the function again, and we get the second point at 2, negative 12. It's really crucial to label your coordinates at this point really carefully. So you write x1, y1, and x2, y2. And now we use our slope formula again, starting with y2, negative 12 minus negative 6.75 over 2 minus negative 1.5. And the minus negatives turn into a plus, and our final answer is negative 1.5. So what that means is that the average rate of change is negative 1.5. And we know that even though we can't see the second point on the graph, we still know it's there, and we can determine the slope using math.